Well, good evening, and thank you for listening to this presentation. As you can see, this presentation is on sentiment analysis of earnings calls and explores using FinBERT or Financial BERT for stock prediction. And this is based off of the sentiment, positive, negative, or neutral, that is expressed through various earnings calls. This project is a bit ambitious, and for this presentation and this iteration of the project, we'll only be looking at Amazon, NVIDIA, and Lululemon as our test cases. But without further ado, let's look at how this project was developed. So the first difficulty was that there was not a readily available data set that had sentence by sentence um, sentiments for the earnings calls that I was hoping for. And so I started by doing a little bit of web scraping, which was a great experience as well. I had to kind of hit a few bumps in the road as I haven't done a lot of this, but establishing a session to initialize the cookies, and I kept getting locked out of Yahoo Finance, even though I have a valid subscription. But eventually we got there, and I was able to grab all of the URLs that related to the earnings calls for various tickers. So in this case, I just used Amazon, NVIDIA, and Lulu, but this could easily be expanded. The one kind of hurdle that I wasn't able to figure out for this iteration was I did end up manually saving everything as a PDF, and that really didn't take that long. It was only about 180 um, earnings calls between the three companies, and between shortcuts and some quick work. It really was faster than I thought, but that would be a very optimally, it would be automated. Um, it was just hard to get around Yahoo's bot prevention. So I am not a bot, I am a real person. But I was able to retrieve all of the URLs, and then that made it a lot easier to just control click each of those, and to make the process a little bit more automated. And then I used the PyPDF2 library, and I read all the data from the PDFs. Using the NLTK library, I tokenized all of that transcript text so that it was in sentence by sentence bits. And then I used the Transformers library and the Process AI slash FinBERT model to build a pipeline for the scoring. FinBERT is a variation of BERT, which is a very famous NLP model that was developed by Google in, I believe, 2018. But FinBERT is just kind of BERT adapted to financial documentation, so that's why I chose to use it. And then from there, I created data frames of the positive, negative, and neutral FinBERT scores from all these earning calls that I had downloaded. This was pretty easy to code up, but it did take quite a while for it to run. It took a couple hours because it was going through the transcripts of about 180 different documents, and they were between 20 and 30 pages each, and then tokenizing each sentence and giving me an analysis of that. And the reason I went sentence by sentence was because you get a lot more of a accurate score by aggregating those sentence scores instead of just taking a FinBERT score of the whole text, which is what I did originally, but it was just overwhelmingly neutral. And so by going sentence by sentence, you have a little bit better um, ability to pick up on those key sentiments. So that's why I did it that way. So then from these data frames, I created and exported this data into CSV files for persistent storage, so that I could come back to it and not just rely on it being held in that data frame variable. And so then we go into the data analysis part. So this, honestly, the pre-processing and building the data set was a lot more time intensive and resource intensive than I anticipated, but it was definitely a learning experience. And so this pre-processing was the bulk of the work. I've worked with the Y Finance library a little bit before, and that was pretty easy to pull the stock prices, um, which was the other obviously relevant part of this puzzle, is having the earnings calls and the stock prices and seeing if there's any sort of relationship between um, the sentiment that is found in an earnings call and the overall end of quarter price, and the percentage change quarter over quarter. And this project could easily be expanded to kind of include the effect that an earnings call has on trading the next day, the next week, see if there is, momentary dips or mountains, climbs. Um, but I just, for starters, did this with a quarter over quarter approach. Um, and the next slide, you'll see I joined both these data frames together and then added some quarterly changes and compared the data for Amazon, NVIDIA, and Lulu. So you can see here kind of in a nice data frame what quarter we're talking about, the year, the quarter open, the close of the quarter, and the price change. Now, I had to do a little bit of finagling because the open of new quarter and the close of new quarter, I did not want that to be the open of the quarter that they were just reporting on, if that makes sense. So if Q1 ends in March and the earning call is in April, I really was interested in Q2's opening and closing price rather than Q1's, because the earnings call for Q1 is what was affecting Q2. So I had to do a little bit of shifting and make sure that was all accurate in order to see if the sentiment did have an effect on the overall outcome. So we'll just go through these results a little bit. I was kind of surprised in a way at the kind of the trend that was seen is there really was a at least less of a gain, especially with negative sentiment, which shouldn't really have surprised me because, CEOs, CFOs want to be very positive to their stockholders, and nobody wants to be a Debbie Downer and use all this uncertainty language, or even worse, negative language. But it was interesting that when negative language was used, the more there was of it, the stock prices typically, the trend really was down. And you can see, I mean, when the Finbert score is closer to 0.02, you're still having what is that, about a 15%, quarter over quarter stock increase. But as the language gets more negative, I mean, right there at the end, when you're at about a 0.13 score of negativity, you're at basically a negative 5%. So that's about a swing of 20%. So that's something that was interesting to see, is that when there is negative language, if there's a lot of it at least, it can indicate, if not a negative stock price change by the end of the quarter, at least a less significant positive gain, which is helpful to note. You kind of see similar stuff for NVIDIA. These numbers are a little more dramatic just because over the last 15 years, NVIDIA has really skyrocketed even more than a company like Amazon. And so when there's very little negativity, you see it being close to 30% increase quarter over quarter, which is insane. And then with a Finbert negative score of about 0.1, you see that number close to a negative 20, maybe a negative 18% quarter over quarter. And so once again, you do see this negative sentiment negatively impacting the price change. And then for the third set of results, here I included the Finbert positive score. I hadn't included that I mean, it's in my Jupyter notebook. I didn't include that in the slides because the positive score seems to be a lot less reliable because, again, of the overwhelming positivity that these financial leaders tend to communicate in their earnings calls. But it's interesting with Lululemon, the more there really was a trend line, the more positive. It did indicate more of a price change, but really not by that much. You see a low positivity, and you're about a zero or a hold quarter over quarter, and then as it goes up to 0.44, which is a very high positive score, only about 10% increase in stock price change. So that's really not that shocking at all. I did find interesting, just I guess just more of a matter of note, is that when there was negative language found for Lululemon, I'm sure this is true of many companies, it had absolutely no effect on the stock price change. And so it's interesting to me. I mean, Lululemon is in a completely different industry than Nvidia and Amazon, and it has enjoyed less success than those other two companies. And so I would love to be able to continue to develop this pipeline to get more results from more companies and to see if negative sentiment is some sort of indicator for, if not a negative stock price quarter over quarter, but at least a slower growing uh, stock price for whatever ticker we're looking at. So I think that there really could be a lot of future work for this project, and I really do plan to work on this after this course is over, but it would be better to further automate the web scraping and specifically the downloading the files. I think that I think Yahoo is set up in a way that bots have to work a little harder. Obviously, that's for a reason, and I would never want to do anything to harm Yahoo or crash them. I'm just trying to download these files without having to manually click on them. The other things that I would consider adding in this project would be utilizing the Law Friend McDonald Master Dictionary with sentiment word list that really looks for uncertainty, and then using that and this other dictionary that I've been working with, the Finbert analysis, to build a random forest model to generate predictions based off the sentiment, and then also to expand features to include revenue, net income, profit margin, and the earnings per share. I hope you've enjoyed thinking about stock prices and sentiment analysis with me, and I appreciate your time, so thank you for listening.